Hi, Toby. Welcome to the podcast.
Yeah, hi Robert. Thank you for having me.
It's my pleasure. All right, let's begin with where you work and what you do.
So yeah, my name is Tobias Augspurger. I'm working for Open Energy Transition. I'm leading the grid mapping activity. Um, we just started a small initiative called MapYourGrid that is funded actually by Breakthrough Energy. That's the company of Bill Gates that tries to do a
Right.
lot in the energy space.
Hmm.
Um, Bill Gates actually envisioned to create an open source operating system in the energy sector.
All right.
And we are supporting this with different open source developments within this company.
Hmm.
Um, yeah, I have a background in actually aerospace engineering. So actually, I'm an aerospace engineer. I worked in aerodynamics
Mm.
for quite some time, instrumentation, remote sensing, so remote sensing instrumentation. Then I switched to EV vehicles and automation of EV vehicles, did a lot of with open source and robotics. So I really got into open source actually by using it in robotics, automating big trucks to move containers on a yard was something we did for DHL for quite some time with open source.
Hmm.
And then I lost my job and did the Open Sustainable Technology Project as a COVID uh, yeah,
Yeah,
thing
right. So you had a
because
bit of time. You thought, I'll get into open source. Interesting. And so there's kind of an arc here towards understanding energy infrastructure and even sort of making sense of that on a bigger scale.
exactly, yes. We really try to create more or less a digital twin of the global electrical grid. Yeah,
Right.
that's the
Okay. Fascinating. So just what are we talking about? We're talking about pylons, we're talking about substations, that kind of infrastructure, right?
exactly.
Okay.
So we map the lines because you can also see the lines in satellite imagery. So our
Hmm.
main source for mapping or raw data for mapping is satellite imagery.
Hmm.
And we can see the pylons or power towers, we can see substations, and we can see even the transmission lines in many cases.
Right, right. So literally those wires across the landscape that are probably thin as what, your wrist or something.
Um, exactly. Yeah, we normally start with the substations, and then
Hmm.
from that you see all the wires going through all the regions and
Yeah,
connecting actually the energy systems of across all the countries. That's
brilliant.
what we want.
Right. So high resolution imagery, you look for the substations, you know that these things are connected by the wires. Sounds pretty straightforward. I think there's plenty of machine learning models out there that can segment objects. What are the challenges there?
Yeah, we use mainly at the moment human beings actually that are mapping the grid in OpenStreetMap. So 70% or roughly about 70% of the grid has mostly actually been mapped over the last 17 years by human beings.
Hmm.
But we are now, let's say, on the last 30%, we are now also investigating um, machine learning approaches to detect substations. That's
Hmm.
the most easiest object you can and biggest object also you can find in the grid.
Hmm.
And but we're also investigating to detect the next power tower. Um, but this comes with a lot of challenges. Um,
Mm. Right. So substations, quite large, regular shapes. You think those are pretty straightforward, but you have other infrastructure which is more challenging, and that's why the human oversight is required to kind of connect the dots and identify all these things as being part of the same network. Is that right?
yeah, that's right. But it's also the case that you find a lot of different um, grid infrastructure that has actually been synthetically created by AI. And at the end, the challenge is to harmonize all this data into one map that is validated. And this is where the human being comes into the process.
Interesting.
Because yeah, you have for one country sometimes 5 or 6 different grid maps or grid data sets.
Mm-hmm.
And what we normally do, we don't copy paste anything in OpenStreetMap. That's very important to understand.
Right.
We use them as a hint layer. So we have our OpenStreetMap editors, and then we show the OpenStreetMap data, and then we put on another layer actually this AI generated or however this data has been generated.
Mm.
And then we have to integrate this data set by validating every data point.
Right.
Every
So
power tower.
got
Every
it. So there's
substation.
basically false positives from the machine learning models. Is that what you're saying?
Yes, it's about false positives, but it's really also about the connections. So, for example, it is relevant at which side of the substation a transmission line is connected to
Right.
estimate the voltage of the line.
Huh.
It's sometimes very interesting to also see what is on the end of a substation. And this is also hard to do with AI, because you find sometimes very different infrastructure at the end. You find bigger loads. You find sometimes just a distribution substation of a city. You find sometimes a big power plant. And this final mapping process of the grid allows us to bring in all this context into the data set. So it's really a journey that you have in grid mapping, and with machine learning, we would not have this. So we could not bring all this knowledge into the grid. We would not have the opportunity also to bring metadata into the grid that is that demands a certain context understanding of the grid. So there's a lot of different layers and context understanding that you need to map the grid.
I guess my next question is, presumably you could train models to do things like identify which side a wire was connected and start to build up some of this context itself, or input those features to another model that could make predictions about, how these things are connected or which class they are.
Let's say it this way, it's technically possible, yes, but there are limitations to that. One is just the data availability for machine learning of this high resolution data. So in OpenStreetMap, we have S3 world imagery, we have Bing aerial imagery, but this data is just being provided by the for the OpenStreetMap community for free to do manual work mapping.
Right.
For every machine learning approach, we would actually need to buy the satellite imagery, and not just one imagery product. And that's the challenge. So for us as a human to validate this data, you have to switch between sometimes 4 different satellite imagery.
Right.
Because the transmission lines for example, in Africa, they go through areas where the age of the satellite imagery and the quality of the satellite imagery is changing a lot. So you go 100 kilometers, then you have to change to another satellite imagery product, then you have to change again, you have to change again. And sometimes for us, we really have to switch 4 times between the same imagery to ensure that this is actually a power tower.
Right. So you would basically have 4 times the problem for a model, because typically a model is trained on one kind of imagery, one kind of target, but here we have a lot more diversity to handle. It still sounds like maybe a solvable problem for machine learning, but I'm getting a good impression of the sort of key challenges.
It definitely is. And there is a very interesting open source prototype that has been developed by a group in New York from Lindsay Labs. and they do substation detection using Sentinel-2.
Mm-hmm.
And since Sentinel-2 is an open data set, it's allowed as a raw data source for OpenStreetMap. And we are investigating this because one of the main challenges is to have the substation. If you have the substations of a country, I would say this is 50% of the work.
Mm-hmm.
Then you just have to connect the dots. This is possible using all the different spectras of Sentinel-2.
Right, right. So there was a solution already developed. I think I've seen that a little while back. How effective was it?
I think the false positives were very little. The segmentation was, the intersection of unit was not perfect, but still very good.
Mm-hmm.
At least from the paper and from the code I've seen, it works actually very well.
Mm-hmm.
And it would be for us good enough, because even if you would have, I don't know, 10% false positives, since this has been validated by a human being at the end,
Mm-hmm.
it's not a problem.
Mm-hmm.
But it's really key for us because every power plant comes with a substation.
Mm.
Every bigger industrial loads comes with a substation. You have actually the whole power infrastructure if you have a good substation detection.
All right. So that sounds like a pretty promising model, just for that particular task. Does it work globally? Are there some reasons why it can't be sort of deployed for this initial vetting of where the substations are?
So the training data set that has been created for this is using OpenStreetMap data as a ground truth. So
Mm-hmm.
OpenStreetMap is used a lot as ground truth validated data set.
Yeah.
And they used actually the polygons and projected then on Sentinel-2 data
Mm-hmm.
and used this, I think, 50,000 substations all around the world.
Mm.
Yeah, the results were pretty good. And I think the only limitation that you actually have is areas where there's just a lot of clouds is always a
Right.
problem.
So optical data set, some places, Amazon or wherever, lots of clouds. Potentially you
Exactly.
need more than one modality to detect the substations globally.
Yes, we investigated also Sentinel-1 data, if it might be possible. I think it could be done, and but it also depends on the size of the substation itself.
Mm.
Like this really high voltage substations, they are so big. You can actually work with very low resolution satellite data to try to detect them.
Mm-hmm.
But those are actually easy to find. For this, you don't need
Okay.
a detection.
Mm-hmm.
The harder ones are the small distribution substations that
Right.
are at the end of the grid. But those are especially interesting for us because the distribution grid is something that you cannot map very well with even with high resolution satellite data, because it's mostly in urban areas. You have the poles
Mm.
sometimes, you can see them, but normally you see poles based on the shadow, or power towers you see always based on the shadow of those infrastructure because they are so tall. And in these urban areas, it's sometimes pretty hard to detect this.
Right.
That's but if you have the distribution substations, and you can use again machine learning and try, and there's a lot of groups trying to estimate the distribution grid using machine learning approaches.
Mm-hmm.
And this can be supported a lot if you know the nodes, the distribution substation that are the nodes of the distribution grid.
Right. So this sort of comes back to your earlier point that the experts use multiple sources of imagery. They've done a lot of personal training. They have an understanding of how grid networks work, and they are able to identify these smaller substations in more challenging areas. But currently, machine learning methods are not there.
We have sort of the substation detection that have been developed so far, using mostly bigger substations. Yes.
Yeah. Okay. Brilliant. So I think that really helps us sort of clarify where the state of the art is and what the sort of the frontier looks like and what the challenges are. Obviously, you've been working to curate a lot of truth data, as you mentioned. OpenStreetMap is often used for generating, annotated data sets for training models.
Yes.
I'm not sure how many people are aware of that and also the richness of the data that you've curated. So I think one thing we want to do is just highlight that that resource exists and is being developed for this purpose, right?
Yes, it's used for machine learning a lot, but it's also used for energy system modeling, like actually to have a ground truth data set. It's used a lot for regional studies, for larger studies. It's used by the World Bank to actually to improve the electrification of, for example, areas in Africa and South America. So this data is really actually the only data set that is standardized for the electrical grid worldwide. In many low to middle income countries, there's actually no good data about the electrical grid. And this is a real problem for investors and for the expansion of this electrical grid.
Got it.
And yeah, OpenStreetMap is used as one of the best sources because it's validated and it's accepted by the community because it's used for years by larger organizations like the World Bank to do investments into the grid.
Right. So significant uses for this data set, not just for machine learning and expanding the data set, but also for understanding infrastructure in a country, enabling investment, etc.
Exactly, yeah.
Brilliant. And interesting constraints, as you mentioned, around sort of licensing of data for particular uses. And then also when you try and deploy these generated locations into OpenStreetMap, there's certain criteria that must meet, like you must be able to independently validate those results using open data. So it's a really interesting context there that kind of guides the solutions people might be looking to develop. Brilliant. That's a really interesting conversation. I think it's a very interesting problem as well. As you mentioned, it's kind of not just detect a thing, but understand how it fits into a bigger network and challenges like the multimodality potentially helping. And I think lots of potential there for machine learning and really highlights kind of the limitations of the current technology. I guess in terms of just to sort of bring things to a head, where are the main platforms where this information is communicated and where you share your own kind of resources on this topic?
So I think one of the best websites to actually have a look on this data is Open Infrastructure Map, or you find it at openinframap.org. And this is a visualization of the global electrical grid data. This is in OpenStreetMap, including power plants, substations, but also all the underground infrastructure. So you will find, especially for Europe and the US, this data is from data quality similar to official data from system operators. If you want to improve this data, you would visit MapYourGrid.org. That's our website. Here you can find our starter kit, our videos, but also some tooling that is just simplifying and automating the process around transmission grid mapping. So we try to standardize a lot around this topic. But also the OpenStreetMap Wikipedia page has a lot of very interesting content. You will find it actually if you search for OpenStreetMap Wiki and power networks. There we will find like a landing page that will give you an introduction into also the topic, but also the local pages from the local groups of people that are focusing on curating, improving the grid data for their country. And they are collecting data there on their country pages. So I think this are the main websites when it comes to OpenStreetMap and electrical
Brilliant.
grid data.
It's great to hear about these global communities working to map their areas, and I just think it's an amazing resource that the community has put together.
Yes, it's really, I must personally say I'm really impressed by the data quality. It's a little bit hard to prove the data quality within OpenStreetMap, and we are investigating this at the moment. Also using machine learning, do random sample approach to take data, try if we can detect it like it's been mapped. But it's really, what I think this is something very special that a lot of people don't understand. How do you curate a data set over 17 years? What is the strategy to improve this data on and on and on, especially when it comes to machine learning, where there's a lot of people that actually are generating data that is being potentially a source, but someone at the end still needs to harmonize all of this. And OpenStreetMap is really a great place to harmonize GIS data.
Yeah. Humans still play a very critical role there, so that's important for us all. Brilliant. Okay, and you're personally active on LinkedIn, I think, so that's probably another place people can follow.
Yes.
Fantastic.
Yeah, and have a look at our YouTube videos. I think they are the best way to have a quick understanding about what we're actually doing.
Perfect. All right, I'll place those links in the show notes. But once again, thanks for joining me today and telling me about this fascinating topic. And I wish your project all the best in the future.
Yeah, thank you so much, Robin.
Brilliant.